For this practice video, we will work out a multi-step equation with finding water, pause as needed, and move on to the next step. For purposes of simplicity in learning, for this equation we will give you just what you need to know for the information to plug into the formula. We use 64 ounces of an 18 index arterial, 8 ounces of a 21.5 index arterial, 16 ounces of a 32 index arterial, and the total volume in our tank is 384 ounces, or 3 gallons. If we were just solving for the percentage of formaldehyde in the tank, this is all the information that we would need. But since we're solving for the amount of water in the tank, we need a little bit more information. For that, we need the amount of supplemental chemicals as well. We have 4 ounces of one supplemental, 8 ounces of another supplemental chemical, and 4 ounces of the last supplemental chemical. As we stated in the beginning, this is going to be a multi-step process. But we can keep things simple for right now. So let's dive right in. Using the information that you are given on the screen, how much water was in the tank? This is simple. What we're going to do is we're going to pause the video at this point. You're going to work out the math, and when we return, we'll give you the answer. The answer is 280 ounces of water are in the tank that makes up 384 ounces of total volume. To arrive at this answer, we're going to take the total volume of 384 ounces. Then we're going to subtract each of the arterial chemicals, and then we're going to subtract each of the supplemental chemicals. By removing everything that is in the tank that we've added from the total volume, we're left with the only thing that we don't know the volume of, and that's the amount of water in the tank. As promised, we're going to make things a little bit more complicated. Now, using the formula that we've learned in the intro video, as well as all the videos leading up to this point, we know that the percentage of formaldehyde in the entire tank, or P, is 4.78125, or 4.8. Now, this percentage of formaldehyde may be appropriate for many cases, but the decedent we're working with today only needs 2% formaldehyde in the tank. So therefore, we need to find out how much water we need to add to this tank in order to make the percentage 2%. At this point, we're going to pause the video. I want you to work out the math, and when we return, we'll go over how we came to that solution. Previously, using the information to the left, we found that there was 280 ounces of water in our tank. Now, by obtaining a 2% solution, we now have 814 ounces of water because we had to add water to dilute our existing solution. The new total volume with the additional amount of water is now 918 ounces as opposed to the 384 ounces of total volume that we had prior. This means in order to obtain the new total volume to dilute the tank, we had to add 534 ounces of water to the prior total volume. To solve this equation, we're going to take the equation that we are very familiar with, and we're going to plug in what we want and take out what we want to solve for. So we know we want 2%, so we're going to plug in 2 in place of P. We're going to remove the total volume that we were provided because that's what we want to solve for. We want a new total volume. So we're now going to have the right side of the equation is going to read 2 times TV. When we work out the left side of the equation, we get 1,836, same number we had previously in this video. We're now going to divide 2 from the right side against that 1,836, the left side of our equation, to solve for the total volume. And when we do that, we get 918 ounces as our total volume. We're not done quite yet. We're here to solve for how much water we need in the tank. Now that we have a new total volume, we're going to take that new total volume and we're going to subtract all of the arterial fluids and subtract all of the supplemental fluids. Same thing we did earlier from the original total volume. And this is going to tell us how much water is in the tank once we remove everything but water from our total volume. To solve for the amount of water in the tank, we're going to do the same thing we did even with a simpler equation. We're going to take the total volume, we're going to subtract the amount of arterial fluid and the amount of supplemental. In this case, we have 88 ounces of arterial fluid and 16 ounces of supplemental once you add them all together. This gives us 814 ounces of water in the tank. This number of 814 ounces works great if we haven't filled the tank yet. But what if we fill the tank? And now we need to get a higher percentage diluted down to a lower percentage, such as what we're working with here, trying to get 2% solution. So in order to do that, we need to know how much additional water needs to be added to the tank, in addition to what's already in there for a total volume. To solve for that, we're going to take the new amount of water and we're going to subtract it from the old amount of water that we had added to the tank. So 814 ounces taking away the 280 ounces that we already had in the tank with the prior solution. We'll get the same answer as if we took the new total volume of 918 ounces in the total tank of everything and subtract that from the old total volume of 384 ounces of fluid of everything that we had in the tank with the prior solution. Now, when we subtract our new numbers from our old numbers, in both situations, you're going to come up with 534 ounces of water that needs to be added to the existing solution in order to dilute it down to a 2% solution. I really hope that this video helped you. Please click the link in the lower right-hand corner to subscribe so you can get more practice problems as they're added.